Hello, in this video I will introduce the Google Earth Engine Cloud Computing Platform. The Google Earth Engine, known as GEE, has been interested by many developers, remote sensing developers and GIS experts in recent years. So they have been using this cloud computing platform in their specific applications. To access the Google Earth Engine platform, you should use this address code.earthengine.google.com. It requires registration, and after your registration has been approved, you can access to this page. This API, the Google Earth Engine API, is divided into different sections. Here at the bottom, you can access to the map. Here we hadn't added any maps, but the default map is map and satellite data. So you can switch between map and satellite. In satellite, you also can zoom in, zoom out, and you can serve whatever you are interested in global scale and take a look at different areas. So this high resolution map cannot be analyzed. You cannot input this high resolution map into your algorithm because this map is not free, but you can just surface it. On the other hand, there are various data that are available within the Google Earth Engine, Landsat data, MODIS data with different resolution, different bands that you can access. Here, this is at the middle of the page, you can access the code editor. You will write your script here, run the algorithm, and see your results. So this is the main section of the GE API. Here at the left side, you have a window that is divided into 3 sections: scripts, documents, and assets. In scripts, you can create different repositories, new repository, name of the repository, and creating a new repository. And in each repository, you will create and save different scripts. So this is your repository. Here is the API documents. You can see all documents are started by EE, means Earth Engine, and is classified into different categories. EE algorithms, for example, image segmentation, Landsat, some specialized Landsat algorithm, for example, classifiers, different classification algorithm, clusterer, for example, image collection. Maybe you require to define different kernels, circle kernel, cross kernel, diamond, and different kind of kernel. So this is whatever you have, you can define at the server side. So you can see you have a script here. You can define your script, but the variables can be defined either at the client side, here, just in your browser, or at the server side, at the GE server. So whatever you should define should be should be defined by EEE different modifiers. So this is this is the section that we will talk more later. Asset is what you save within your GEE account. In your GEE account, you have limitation. At this total file size, you can save 215 gigabytes, and the number of assets is limited to 10,000 assets. But to my experience, the main limitation is total file size. 250 gigabytes is not too much for large scale analysis, continent based analysis, and also global scale analysis. So because consider that GE is free, so you will have some limitations at the file size and also at the computation. You can also upload some images into your assets. Image upload, shapefile upload, and also CSV upload. So you can upload data, you can save data, you can export data, you can play with your data. Here at the right side, we also have 3 tabs: Inspector, Console, and Tasks. Let's start with Inspector. Using Inspector, you can inspect the map. If you click here, you can see latitude, zoom level, and scale. Zoom level and scale will change by zooming it and zooming out. For example, we zoom in here, click here, zoom level increases and scale will decrease to 0.5 in its submeter. And if we zoom out and click here, latitude and latitude are the same, zoom level decreases, scale is about 4.7 meter per pixel. Here, as I said, we hadn't add any layers into the map, so we just have this information. But if we have added any data to the map, and we click on the data, we can see the pixel value. We can see the data value using Inspector tool. Console is console output. If you have used any programming language interface, console is console. It's available in all programming interfaces. So you can print your data here. You can see your plot here. So this is the console output. We also have another tab named Tasks. In Tasks, you can run different algorithms. For example, you created an algorithm to classify the US into different number of land cover classes. For example, human settlement area, vegetation area, forest area, open water area, bareland area, different kind of classes, and you are going to classify the whole US. You are going to classify the whole US. So your result will not be ready instantly. It takes some time, and you can submit your tasks, and it will last according to how large computation you are running. It could be 1 hour, 11 hours, 1 day, 7 days, less than a minute, or it could be 4 days. It depends on what you are running. But the point is, you can submit your task and you can close your computer, you can shut down your computer and do your other works, and Google Earth Engine is running your algorithm to prepare your map. So it's not required, to be online, to be connected to the Google Earth Engine server to run the algorithm. It could be run on the background. Besides, we here have you can search the places and data sets. Before searching a place, let's take a look at data catalog. One of the most useful aspects of GE is its rich data catalog. Let's take a look at its data catalog. Here, data catalog, you also have several tabs. Landsat, MODIS, Sentinel are the most popular remote sensing data, so they have their special tabs. Let's take a look at Landsat tab. In Landsat, we can see different Landsat collection from Landsat 8, Landsat 7, Landsat 5, Landsat 4, and also Landsat 1, 2, and 3. Besides different Landsat satellite data, we also have different level of processing. For example, for Landsat 8, we have top of atmospheric data, but we also have surface reflectance data. When satellite is capturing data from Earth, it will be emitted through the atmosphere. So the atmosphere will affect the signal that the satellite receives. So there are different levels of processing to create the data. We could have top of atmospheric data, we could have some of atmospheric correction, terrain correction, different kind of correction to create, different level of processing. For example, this is Landsat 8 level 2 collection to tier 1. And each of categories are defined by the processing and the quality of the data. USGS provides this data, and USGS by itself knows that some of images are not very useful for surface monitoring. So, for example, it puts in tier 2 data, not in tier 1. Let's back to, for example, taking a look at Sentinel data. Sentinel data is, Sentinel collection is provided by ESA, European Space Agency, in Copernicus program. It also has different satellites. Sentinel-1 data is radar data. Sentinel-2 is multispectral satellite. Sentinel-3, Sentinel-5. It also provides different satellites for different applications. You also can take a look at view all data sets to take a look at how many datasets are available within the Google Earth Engine. It's a long list. You can take a look at it. But here the tag, browse by tag, is very useful. For example, you can take a look at, you can search also nighttime lights. For nighttime lights, you can see what is available within the Google Earth Engine. But let's come back and take a look at what we have by nighttime tag. For example, we can click at nighttime tag and see that for nighttime we have DMSP OLS, version 4. Some corrected, some of them are corrected, some of them are non-corrected. So this is a useful feature within the GE, that each image and each image collection has some tags that you can search and find your desired data. Okay. Before finishing this introduction video, let's take a look what we have in each data. In each data, we have a description that describes the data. This is also very useful, which is provided by Google, and it provides the basic idea what you can use this data for. It also provides the bands, and you can take a look at each image or each image collection bands. For example, for this DMSP OLS version 4, the data availability is from 1996 to 2011, and it has two bands. The first one is average of visualization value, but here you can see the confidence level, how many times each number, how many times each numbers were each pixel were observed to produce the data. So it creates the confidence of each pixel. Here we have the term of use. You can, if you use each data, it's highly recommended to cite the providers. But here at the bottom of the page, there is a sample code that you can use opening. If you click here, opening code editor, it opens for you. Here we can take a look. It provides a sample code to how to use this data. For example, here it opens the data. I'm not going to talk about different kind of data, how to define this data, but I just want to run the data to see how this API works. To run the script, we have run button here. We run the script. I'm not going to talk about the script itself, but here we have the map here, the nighttime light map. You see, we added a map here, nighttime light value, and you can take a look at it. Let's use the inspector tool. Inspector, click at area here. Besides the point, what we have before, line to line to zoom level and scale, which is not very important. Here we have the pixel value. For example, it's about 857. We can click here. It's 0. You can click here at the border of the city. It's about 32. Let's use the high resolution map to show what we are looking at. Before finishing, let's print something, print anything. We have the nighttime lights, and we are just going to print the nighttime lights. Running it, and here at the console, nighttime light is an image collection with different specifications, different images, different properties. So I'm not going to also talking deep about the image collection, but just going to talk about that. We can print whatever we want here. It could be image collection, it could be a single variable, it could be also an image, and also we can also print the plot here and taking a look at the plot. So this was just an introduction, and we will continue within the next videos.